Here is a strange fact about language models. Between one call and the next, they remember nothing at all. Each request starts from a completely blank slate. So how does an agent work through a task of 10 or 20 steps, calling tools and building on what it just learned, if it forgets everything the instant a step ends? The trick is a running workspace the agent writes into as it goes and reads back on every single turn. It is called the Scratchpad, and it keeps an agent's reasoning coherent. Let's dig in. So what actually lives inside this workspace? Follow one full turn through it, piece by piece. Each turn begins with the agent writing down its reasoning. In plain language, it thinks out loud on the page, something like, I need to find a user's order, so I should search the database. This written thought is not decoration. Putting the reasoning into words sharpens the decision that follows, the same way chain of thought helps a model reason better. Next, it records the action it decides to take. Which tool did it call, and with exactly what arguments? That call gets appended to the Scratchpad as a concrete, log step, so the running history now holds not just what the agent was thinking, but what it actually did about it. Then it appends the observation that comes back. The tool returns a result, a database row, a search snippet, an error message, and that result gets written into the Scratchpad right after the action that triggered it. Now the log holds a complete little episode, a thought, the action it led to, and the outcome the world sent back. Finally, the whole accumulated trace feeds straight back into the next prompt. On the following turn, the model sees everything it has thought, done, and observed so far, and decides what to do next with full context. This running thought, action, and observation trace is exactly the structure of the React pattern, interleaving reasoning and acting. So why does this humble text log matter so much? Here is the contrast laid side by side. A stateless model forgets its own steps the moment each call ends. Without somewhere to record what it just did, it wakes up on every turn with amnesia, unable to remember which tools it already tried or what they returned. It would repeat itself, chase its own tail, and never progress past a single exchange. A Scratchpad gives it a running log of everything that happened. Thoughts, actions, and results pile up in order, and because that history rides along inside every prompt, the model can build on its own prior work instead of starting over. This is the short-term working memory that makes a multi-step reasoning loop actually hold together across many turns. Strip it back, and 3 ideas define the Scratchpad. It is a running log of the agent's thoughts, actions, and observations. As the agent works, each intermediate reasoning step, each tool call, and each result it gets back accumulates in order, building a full trace of how the task has unfolded so far. That trace feeds back into the prompt on every single step, which is what keeps the loop coherent rather than amnesiac. The model can see its own history, avoid repeating work it already did, and reason through a long task over many turns, building each decision on the ones before it. It keeps growing with every step, and that growth is the real catch. On a long task, the Scratchpad can overflow the context window and balloon the cost, so agents summarize it, truncate older parts, or offload them to external memory. Managing the Scratchpad well is a genuine part of building reliable agents. All right, let us lock in the essentials. An agent Scratchpad is the running workspace where an agent writes its thoughts, actions, and observations as it works through a task. That whole trace is fed back into the prompt on every turn, so the model builds on its own prior steps instead of forgetting them each call. It is exactly the structure behind the React pattern, interleaving reasoning and acting, and it serves as the short-term working memory of an agent. Just watch the growth. since a Scratchpad that overflows the context window has to be summarized or offloaded to keep an agent reliable. If you enjoy the moving parts of AI agents made this simple, come explore the rest with us at standarity.com. See you inside.